All right, Algebra 2. So after we took a look at the Desmos activity with balancing the hangers and then worked our way through that quizzes where we tried to identify what would be my next step in solving a particular type of equation. I think those two things went together really well. We looked at the idea of keeping an equation in balance, so taking the same thing off of both sides, doing the same thing to both sides of the equation. So we got a very visual look at solving. And then we went in and we got to the nuts and bolts of it. What is the actual next step that I'm going to take? And so the class that just finished had about a 71% accuracy. Things are really, really solid in terms of being able to identify a next step. And so I wanted to take a look at a couple that maybe we could use a little shoring up on. So in particular, a lot of these equations were equations that featured variables on both sides. So as an example, 3n minus 4 equals negative 2 plus 2n. So as we think about this type of equation, I've got variables on both sides. I need to collect all my variable terms on one side of the equal sign and my constants on the other. And it literally does not matter which side is which, but a thing that I've always suggested to my students and a thing that worked for me as a student is I want to get a positive coefficient on my variable. So when I start to think about, well, should I eliminate the 3n or the 2n, my approach is going to be, which one is going to leave me with a positive coefficient? So I look at this and I go, well, if I subtract 2n from both sides, that will leave me with 3n minus 2n is 1n minus 4. 2n minus 2n goes to 0, so this side has just negative 2. So one of the things that we've talked about in a couple of my classes is this idea of being able to use your test-taking skills to work your way through these types of problems. And so I know that I could start by collecting variables on one side, or I could start working with my coefficients. Like say, for instance, I decided I wanted to add 4 to both sides. Like, is that possible? So if I take a look at my options, add 2n to both sides of the equation. Well, I did decide that I wanted to eliminate the 2n, but we're not going to do it by adding. If you take a look at the equation itself, I have a plus 2n, and so to undo that, I need a negative 2n. Here, I'm asked to add 3n to both sides of the equation. Again, same story. This is a positive 3n. We're not looking behind it at this sign. We're looking in front of it, and I don't see a negative here, so I know this is positive 3n. So subtracting that is not going to help me. Subtract 2n from both sides of the equation. Well, that's what we settled on, okay? And then either of the constants, if I go to subtract them, they're already negative, so that's not going to undo anything for me. So let's go ahead and take a look at what's the process of solving this. So we recognize if we subtract 2n, we're going to get a positive coefficient. So I need to undo subtracting 4. So add 4 to both sides, and n equals 2. Okay. Let's take a look at another. So here was an example where we had, I'm going to scoot my paper over here a little bit, about a 40% accuracy. K plus 6 equals negative 4k plus 9. And so similarly, if I subtract k from both sides, I'm going to have a negative coefficient on my k, and I don't really want that. Okay. Subtracting 9 from both sides of the equation, this is already negative, so that's not going to help me. Subtracting 4k from both sides is not going to help me. What I want to do is add 4k. So adding 4k here and here, 1k plus 4k is 5k plus 6 equals negative 9. So what could I do from here? I'm still trying to keep my variable term for last, right? So I'm not going to tackle the 5k right now, but I need to undo adding 6. So So positive 6 minus 6, that goes to 0. Negative 9 and negative 6 is going to give me negative 15. So one of the things to keep an eye out for as you're solving equations, there's nothing that says that we can't have some really bizarre solution. But in a lot of the practice problems, when your teachers write these, or textbook companies or worksheet companies, a lot of times, at least in the early going, they want your answer to come out to be nice and neat. So if I'm combining negative 9 and negative 6, and I get something like negative 3, and then when I go to solve this, I get some weird fraction, well, I mean, maybe that's the case. Maybe that's true. And remember, you can always check your work. If you got k equals negative 3/5, put that back up in here and see if it makes a true statement. But more than likely, negative 9, negative 6, that's negative 15. More than likely, this is going to be written so it comes out to be a nice, neat integer answer. So k divided by, 5 divided by 5 is 1, so 1k, and then equals negative 3. All right, not too bad. I did want to take a look at one more with you. And so this one has a little bit of a hook to it. Okay. So we've already done a little bit of practice here. What I'd like you to do now is go ahead and pause your video. All right. So let's take a look at this two different ways. First off, let's follow along how the quizzes wanted us to solve this. So adding 6 to both sides of the equation, this is already positive. That's not going to help me. Adding 10 to the both sides of the equation, this is positive. That's not going to help me. Adding 7x to the equation, that's already positive. That's not going to help me. So subtract 7x from both sides. Okay, well, that's the only option they give me that's a legit next step. So let's go ahead and solve this that way. Subtract 7x, subtract 7x. So how is that going to look? 3x minus 7x, that's negative 4x, plus 6 equals 10. And then the 7x minus 7x, that sums to 0. So now I'm trying to keep my x term for last. I need to undo adding 6. Let's subtract 6. 6 minus 6 goes to 0, so my left side is just negative 4x. 10 minus 6 gives 4. And then here's the reason why I work to try to keep a positive coefficient. Like, I'm a math teacher. I consider myself kind of nitpicky. And still, it's easy for me sometimes to forget or leave off my negative sign. I have negative 4x. I have to divide by negative 4 here and here. And one of the most common mistakes my students make is to not divide by the negative. So negative 4 divided by negative 4, that equals 1. So my left side is 1x. 4 divided by negative 4 is negative 1. Okay. If you went through and you worked this on your own and you worked on trying to keep a positive coefficient on x, you would have subtracted 3x from both sides. So 6 equals 10 plus 4x. Now we subtract 10 from both sides, and I have negative 4 equals 4x. So I'm still going to end up with my negative 1 for my solution, but I can kind of see here that I'm dividing by a positive. Right? And so as long as I recognize a negative thing divided by a positive thing is going to be a negative thing, I'll still come up with negative 1 for my answer. So I just wanted to take a minute to kind of point that out, that little nuance of solving the equation that way. So we did some really good work in class today. I appreciate your efforts in terms of working through step by step on solving